So we're going to be working on doing workshop number 6 that has to do with homework task 7, and we're talking about functions and graphs. Okay, so let's start off with problem 4 with house algebra. So go ahead, you guys. You guys have got the floor. And as we've done before, you guys are going to share the problem, and we're going to go review it and make any corrections if necessary. Okay.
Well, I did this one, but I'm pretty sure that it is going to be incorrect.
Well, let's have a little bit more faith. Maybe it's not. Maybe it's completely correct. But if it's incorrect, then this is a learning moment, and we'll make any adjustments. So go ahead.
So I started by factoring out by swapping the sides of the equation and equaling it to 0, and then in step 2 I decided to factor out x from the equation like how we've been doing all this semester, and then step 3, well, we started to add and subtract the x so that we could factor out x. So we could factor out x to the 2 from the expression in step 4. And well, I had a really hard time trying to solve this. That's why I say that it's not correct.
Well, let's back up a little bit. Okay. Let me. So just to verify, the people, I'm sitting here in front of the computer, but the people at home, can you hear me without a problem?
Yes, I can hear you.
Yes.
Okay, good, because I'm a little bit away from the microphone and just checking. I'm actually using the microphone of the computer. So, no, I'm using this. Let's just give 2 steps back here before we continue. I'm gonna stop sharing just for a moment, okay? Alfredo, let's stop sharing there for a moment, and let's go to our homework task and just look at the problem. And first off, let's review what the problem is asking us to do, and then go from there. That's that's very important. So we've got homework task 7. And I'm going to do this and share my screen. So we are in homework task 7. Okay. And you guys had problem number 4. Right? Problem number 4. Now, Alfredo, you're going to help me out. We're going to solve this one together. Okay, Alfredo? So first off, Alfredo, what is the problem asking us to do?
To determine if the function is even, odd, or neither.
Neither. And we're not going to do it with the graph. Okay, everybody's in sync with that?
Yes.
So can somebody remind us, how do we know if a function is even or odd? What do we check? How can we check that? Anybody? Go ahead, Daniel.
If we are going to check that, we are going to, depending, if it's even, f of x is going to be equal to minus f of x, I think.
Correct.
And if it is odd, minus f of x, it's equal to f of minus x. I think.
Yep, let's go with that, with what Daniel is mentioning. Okay, so Alfredo, are you still there?
Yes.
Okay, Alfredo, help me out here. Can you tell me the equation, the function, please?
Yes, it's f of x equals x to the power of 5.
Just give me one moment here. This is problem number 4. And, okay, again, I'm sorry.
F of x equals x to the power of 5 plus x to the power of 3 plus x.
Okay. That's the function, okay?
Mhm.
Now, we need to find out if it's even or odd. Now, what I'm a little bit concerned about with the procedure you guys showed is that you're given a function and the first thing you're trying to do is to solve it. Right? We're not being asked to solve it. We're just being asked to find out if it's even or odd. And to find out if it's even or odd, if f of minus x is equal to f of x, this means that it is even. If f of minus x equals minus f of x, this means that it's odd. And if none of those two situations happen, it means it's neither even nor odd. Okay? So, Alfredo, are you still there?
Yes.
Choose a member of your team, of your house. Anybody.
Ana Fernanda.
Fernanda? Okay, Fernanda. Alfredo put you on the spot. So Fernanda, we already did this exercise, Fernanda. Give me a number, any real number, whatever real number you want. 2. Perfect. That is the perfect number. I love 2s. Fernanda chose 2. So I'm going to say that x equals 2. Okay? That's the number I'm choosing. So I'm going to choose x1 equals 2 and x2 equals the negative version of that one, which would be minus 2. Okay, are we okay to that point, Alfredo?
Yes.
Okay, so now, Alfredo, do me a favor. Calculate this, f of 2. F of 2, Alfredo, means substituting 2 into the function and finding the value. Do that calculation, please, Alfredo.
Yes, can you give me like 30 seconds?
I can give you 25.4 seconds to do that. Fernanda, choose a member of your team now. Now, that can't be Alfredo. I know she bounced it to you, but you need to choose somebody else. Daniel. Help us out here, Daniel. And you have, because it's negative, you have 25.4 seconds to calculate f of minus 2. Please. Are you there, Daniel? You seem scared. You okay?
So it would be minus 2 to the 5 plus.
Yeah, by the way, both Daniel and Alfredo, you can calculate it. You don't. I'm not expecting you to do it mentally. Do the calculation.
Okay, okay. I was
Yeah,
like,
it's not mentally.
what?
Okay. No, chill. It's just, I just want the number here. I'm gonna do the Jeopardy song. While they do the calculations, I'm going to explain why I love 2s.
Teacher,
Is
is it 42?
Oh, perfect. Let's see, Alfredo.
42.
Well,
You got 42, Alfredo? Okay, let's see. So it's 2 to the 5 plus 2 to the 3 plus 2. 2 to the 5 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. 2 to the 3 is 8 plus 2. This gives us a 42. Correct, Alfredo. Daniel, you got your number?
yes, I got minus 42.
You got minus 42. So now let's see that one. If we've got minus 2 to the 2 to the 5, I'm sorry. plus minus 2 to the 3 plus 2, I'm sorry, minus 2. This would be minus 32 minus 8 minus 2. This is minus 42. Okay? Now, Alfredo. Now I ask you, Alfredo, is the function even or odd?
Well, I think it's well, even.
Well, that's a tricky question. You've got two options. It's like throwing a coin in the
Because
air and see.
because we have, I don't know, I think it's even.
Nope, it's odd. It's very simple, Alfredo and the rest of the group. We've got a number which is 42. And we've got a number which is 2 and the negative version. If I get the same number here, it's even. But if I get the same number with a different sign, it's odd. So I ask again, Alfredo, is it even or odd?
Well, odd.
It's odd because I got 42 and minus 42, okay? If I would have gotten 42 and 42, then it would have been even. If I would have gotten two totally different numbers, it's neither even nor odd, okay? Is that clear? So this function is because f of minus x is equal to minus f of x, okay? Meaning f of minus 2 is equal to minus f of 2, then the function is odd.
And that's the whole problem.
That's what we needed to do.
So I overcomplicated myself.
Well, just a little bit, Alfredo, but something very important. Again, we need to look at the instructions to see what we're being asked to do. This is the only thing that we're being asked to do. Find out if the function is even or odd.
And I have a question.
Go ahead.
In the instruction, it said that determine if it's even or odd, or if it's neither of even or odd. What would be the situation that it's not even nor odd?
That's a perfect question. So the situation that you're talking about, let's imagine that we would have done this calculation, Alfredo, and instead of the 42, I would have gotten 35. And then I do the calculation over here and I get a 21. First off, are the numbers the same?
No.
So it's not even. Are the numbers the same but with opposing signs?
Nope.
Then it's not odd. Are the numbers totally different?
Yes.
So it's neither. It's neither even nor odd.
Okay.
Now, so is this one clear? Questions with this one? Alfredo?
Nope.
So Alfredo, we're gonna do the following. I need help from everybody.
Teacher,
Go ahead. Luis, go ahead.
why do you use in this problem 2 and minus 2?
We could have used any number, Luis.
Okay,
2 minus 2 is because I asked Fernanda to give me two numbers. So let's do this exercise very quickly. Luis, give me a number, whatever number you want.
yeah, 3,
Make it a simple number to do calculations. But give me whatever number you want.
3.
3. So let's say that we calculate very quickly f of 3. F of 3 is, help me out with the calculations here, Luis. 3 to the
Yes.
5 plus 3 to the 3 plus 3. This is going to give us, give me the number here. My brain is mushy right now. lack of sleep, and then do the calculation with -3. Calculate that, please. Please, those two numbers. Let's see, 3 times 3 times 3 times 3 times 3. 243. Are you there, Luis? Luis, are you still there?
Yes.
Okay.
If the first one is 700, it's 200, 700 and
700? Oh, that's, you sure?
I did it 3 at the power of 6. Oh my bad.
So it's 3 to the power of 5.
Yes, it's 173.
173, no?
It's 200,
200 and,
273.
no? 223?
73.
But remember to add everything, so 3 to the 5 is 243 plus 27 plus 3, yes, 273.
Mhm.
Okay, correct. And what do you get when you do it here? You get minus 243, minus 27, minus 3. This would be minus 270.
Yes, it will be negative.
Yeah, you see that you get the same number, but with opposing signs. That is going to happen with any number.
Okay.
Okay, so when it's even, when you're trying to test if it's even or odd, you can choose whatever number and just substitute. Okay, except 0, obviously. Okay.
Okay.
Okay. Now, everybody turn off your cameras for a second, except Alfredo. Everybody turn, yes, perfect, perfect. That's what I'm looking for. I'm gonna do that. There we go. Can you please speak, Alfredo? Just give me a moment to put the screen here how I want it. There we go. Okay, can you please speak, Alfredo?
Yes, teacher.
Speak and give us a thumbs up.
Hello.
And give us, no, but with your hand.
Like this?
Yes, keep speaking, say hello, 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 hello.
Hello, hello, hello.
Oh, I need to shut up so this works.
Hello, hello,
Okay.
hello, hello.
Perfect, there we go, thank you. So you're gonna be on the screenshot of the problem. Was this clear, Alfredo?
Yes.
And the rest of the group?
Yes.
Okay, good. Thank you. Thank you, guys. So let's remember to read the instructions. It's important to read the instructions. Okay, let's go with, let us go now with the next house. A moment here.
Teacher, and one last question.
Yes, go ahead.
And to confirm if it's odd or even, you just with the negative number, or just put the minus aside from the answer, and if it stays negative, it's odd.
If when you substitute the same number, positive and negative, you get the same number with opposing signs, it's odd.
Okay. Thank you.
Okay, so the next one we've got, let's go with deathly signs, problem number 6.
Okay, so here we have that f negative x is equal to negative f of x, and to prove this, we substitute with 4 and minus 4, and we got negative 0.23 and 0.23. Since we have the same number with different signs, it's an odd function.
Perfect. So it's the same procedure we're talking about. In the case of house definitely signed, you guys chose a 4. Substitute 4 and minus 4. We get the same number, but one is positive and one is negative. That would mean that the function is odd. Okay, perfect. Perfect. Good job. Good job, you guys. Remember, if anybody has any questions, we'll stop and answer them. Let's see, house pi waves.
Oh, so problem 8 is the same instructions, and we have f of x is equal to the cubic root of x to the 3rd power plus x, and we substituted a 4 and minus 4, and we get cubic root of 68 and cubic root of minus 68. And with cubic roots, you do get a result. It is not like in the square roots where it is undefined. So we have a positive value and a negative value, and we get that this problem has an odd symmetry.
Okay, good. Now, just a quick note here, just to reinforce what Alejandro was saying. So here it's an odd root. So this is the same as having the root 3 of minus 1 multiplying 68. And this is the same as having the square root of the 3rd root of minus 1 times the 3rd root of 68. And this is going to be equal to minus 1. So this is equal to minus the square root of the 3rd root, I'm sorry, of 68. Okay. And so if it's an even root, that's where we can't have negative numbers inside the root, but since it's an odd one, then we can. Okay, so good job there. Give me a moment. Okay, thank you. Good job, you guys. Good job. Let's go with jokers with problem 10. I think this is the last batch of problems that have to do with even or odd functions.
Okay, so this is the same set of problems, and we had to determine whether this function was even or not or odd. And so we just tested the values like you did before, checking the same numbers if they stay with the same sign, and they did. So we determined that the graph was odd, and that was everything we had to do.
So here we're incorporating the concept. We're going to see that in a bit. The concept of the absolute value. We already talked a little bit about absolute values. Sorry, we haven't talked about absolute values in functions. However, we've got x multiplying the absolute value of x. So the number, you guys did a tabulation here where you calculated many values to check this. So basically what's going to happen here is that whatever number we put here is always going to be positive. Okay. And so the sign is going to be determined by whatever number we put here. So that means that if x is positive, the result is going to be positive. If the number is negative, the result is going to be negative. Okay, so we see here if I substitute minus 2 and 2, we're going to get the opposing values. Okay, if I substitute 1 and -1, we're also going to get the opposing values, so they're odd. All the ones in these odd even problems seem to have been odd. Okay, good. Good job, you guys. I didn't mention why I didn't finish mentioning why I like twos. So my birthday is, oh, sorry, I was gonna write there. Let me write over here then. So my birthday is the 22nd of February of 1975. If you add 1 + 9 + 7 + 5, you get a 22. That's why I like twos. Twos everywhere. Okay, good. Let's go with, we're back with house algebras with problem 12. Go ahead, you guys.
So here we are to determine if the function is even, odd, or neither. But I had a question in here. For example, we know that when by using the chart of the types of functions, that this is to the 3, but because it's going to the opposite side, it's to the -x to the 3. But it's repeating, so I solved it as if it was just like the one squiggle line, but I'm not sure if it's correct. So if we were to do it like how I understand it, I think it's correct, but I'm not sure. So if we were to choose any number and substitute it in the function, which is -x to the 3, we can determine if it's even, odd, or neither. So we substituted 3. So it would be like this, minus parentheses 3 to the 3, and it gives us -27. And if we substitute the -3, it would give us 27. But I think that's just one line. I'm not sure if it's all the same for the whole function. I'm not sure in that case.
Okay, good. Let's talk a little bit about this. The result, the result is correct. The function is odd. Okay. We actually can't make this assumption. Okay. Now, I'm sorry, you are mentioning, Daniel, that it kind of looks like x to the 3. But actually, it's x to the 3 and it's moved. It's shifted because x to the 3 crosses the origin. And the other thing is that it's periodic. So actually, we don't know the function. Okay? We don't know f of x. We don't know how f of x looks. The only thing we can work with is the graph, is the plot. Okay? That's the only thing we can base our assumption. Okay, so let's look at the plot. And remembering that even and odd functions have to do with symmetry. An even function is going to have symmetry with regards to the y-axis. Remember, that's like putting a mirror in the y-axis, and what you have on the left has to be exactly the same as you have on the right. So let's look at the function. Let's see, Miguel. Let's do kind of a test to see if it's even. And for it to be even, we have to have exactly a mirror of what we have on the right has to be replicated over here on the left. So, excuse me?
I don't think it would work out.
It wouldn't, and let's see why. Let's grab whatever section of the graph. Let's say this one here. If I put a mirror, if I were to put a mirror here, Yes,
I think the way easier solution it would be to draw that graph in a piece of paper and just fold it. And if it doesn't
Yep.
connect correctly,
exactly. That's a good idea that Miguel is saying. So we could just draw this on a piece of paper and fold it. And it's like kind of like, have you heard of the Rorschach images that they do in psychology? That you put a blot and then an ink blot and then you just fold it and it's a mirror image on each side. That would be exactly what would happen here. So assuming we did that, let's use our imaginations. Assuming we did that, then would you agree that what we would get is a graph, or what we should get is a graph like this? So the orange, if it were even, it would look like the orange, okay? It would be reflected. So is it even? It's not, okay? Now let's analyze so it's not even, okay? Now let's analyze if it's odd. If it's odd, it's going to have what's called symmetry with regards to the origin. So now imagine that you put a mirror here along the origin, across the origin. And what you see on one side of the mirror is what you should see on the other side of the mirror. Or another way of seeing it is that what you have in one quadrant here, you should see in the opposing quadrant over here, okay? Now, what do we see when we try to do that experiment? First off, we've got this little section here that's reflected on this section here, and we've got this section over here that's reflected on this section over here. So these two mirror each other out, and these two mirror each other out as well. So is it odd? It seems to be an odd function, okay? Because the symmetry is with regards to the origin. So what we can conclude from the information we have from the graph is that, well, here. The function is odd, okay?
Yes, so I can never assume the function.
If you don't have if you're only given the graph, you can't necessarily assume what function it is. Actually, this graph that we're looking at here would be closer to, and I say closer because again, we don't have the function. This would be closer to f of x equals the tangent of x.
Okay.
Actually, but I can't even assume that it's the tangent because it kind of looks that way. But it can actually be any function, okay? When we're given just the graph, we need to determine if it's even or odd based on the symmetry. And either we have symmetry with regards to x, or we have symmetry with regards to the origin. And if we have neither, then it's neither even nor odd, okay?
Yes, thank you.
Good, good job. Questions with this one before we move on? Okay. Okay. Already saved this one. Okay, good. Let's jump over to Deathly Signs with 14, please. Go ahead.
So,
You can, do it from your, yeah, we're gonna, you can do the explanation. Let's do this because of the microphone, right?
Yeah.
Okay, let's do it this. Let's do it from here, from this, and you can do it standing up or sitting down as you wish. Can you, so speak, Miguel?
yes, hello?
Can everybody hear Miguel?
Yes.
Perfect,
Okay.
go ahead, Miguel.
So, like the teacher just said, if we put a mirror in between the y-axis, we should have the right side and the left side reflected.
Okay, I'm gonna help Miguel out here. So if we put a mirror right here in the middle, y-axis, let's do this. Let's do this. Give me a moment. Just one moment here. Let's do this. So right now, star of the show is Miguel. There we go. Perfect. So now go ahead, Miguel. You were mentioning, you were saying.
Yeah, if we put a mirror in the y-axis, we should have the right, oh, what's it say?
The right-hand side?
Yeah, the right-hand side and the left-hand side exactly is the same.
It
They
would,
should collapse.
they would be mirrored. This is what we mentioned. It's kind of like the Rorschach that they do in psychology, where you put an ink blot and then you just fold it up like you mentioned. And so the same thing that we have here on the right, it's going to be mirrored on the left.
Yes.
Okay, and that means that the graph is even. Perfect. Okay, all right, correct. Thank you. Good. Good job. By the way, I just want to clear up something just so there's no confusion. I'm not I am not concerned about interacting with you guys. So when Miguel was coming over to when you were coming over to the whiteboard, it's not that I didn't want you to be here or I felt uncomfortable or anything like that. It's just that I'm trying as much as possible for us to follow the protocols that have been established. So let's do this. Whenever we're going to have a presentation that you guys are going to participate, we can do it either way. You can, I'm going to project and I can help you out, and you can come as close as you want, as close as you can to the microphone, or you guys can present from your stations. Would that be okay? And it's not that I'm afraid of you guys or anything like that. I just want to follow you seem like nice people. I mean, I don't know you the first time I've seen Luis's face, but he seemed like a nice person. Nice. He seems like a nice people. That was terrible English. He seems like he's a very nice person. He's got a hoodie. So, and I like hoodies, but I don't know if he's going to attack me or anything like that. But no, you can wear your hoodie. That's fine. So I just wanted to explain that. Let's see. We've got, let's go with House Pi Waves and 16.
Yes, give me a second.
Sure. While Leo sets up, this is the only time I've seen Luis. So there's Luis. Luis is saying hello. So Luis,
Yes.
what are you studying?
Industrial engineering.
Global program, etc.
Global. Industrial engineering, global. Industrial engineering, global program, etc.
Perfect. And that must be really, really difficult.
Yes, that is.
And you must be really, really smart.
Yes.
So this was important to do this right now because you guys have the face masks on. So it's not the same doing the if you've got the face mask. So Luis really transmitted the security there of his answer. So we're gonna be practicing this. Math is important, but this is also important as well. I think we've got Leo.
Yes, can you see the PowerPoint?
Yes, we can. It's perfect. Go ahead, Leo.
Okay. Oh, let me do something. Okay, the problem says set the complete the graph of the given function y equals f of x. If f is an even function, so here, can you see my mouse? Or not?
Yes, we can see the pointer.
Okay. So here f is an even function. So I drew the, like here in the example, like the first line. And then I did the second line that is like reflecting here in the y-axis. And I gave the, like the explanation why. Then b, f is an odd function. So I did the first line as the example, and then if it's odd, the line will go like reflected but inversed. I don't know how to say it. And then I give this, but I have a doubt here because I found that I don't know. I found in a web page that this one has to be like in the zero, and they will have like they have to like intersect here. So this line will be like needs to be like shifted like right here, and then the other one has to start from here to the other side. But I don't know if it's correct or not.
Okay, good observations there. Don't remove the slides there. And let's comment a little bit about that. So first off, this is correct. I'm just gonna draw a little bit. So basically, we've got the function here, and if we're going to do a mirror along the y-axis, then what we should see is the other part going this way. So that would be the even function, okay? So this is correct. However, for the odd version, we've got the function here, and now we've got a mirror that goes along the origin. So imagine that we're putting a mirror here. So actually what's going to happen is that, so just so we can understand what that means, putting a mirror horizontally along the origin means that we're reflecting opposing quadrants, okay? So this would mean that the function, the mirrored function, should go like this, okay? Again, we are mirroring the opposing
Quadrant.
the opposing quadrants, okay? We're mirroring the opposing quadrant. So whatever is in the first quadrant is going to be in the third one. Whatever is in the second one is going to be in the fourth one. And so
I found that maybe the formula has to be like the f of x, the f parentheses negative x, and then something like that, plus the one for the shifting up, because it's not in the x-axis. I don't know if it's correct.
yeah, let's work with that. Let's go with that little. So let's assume the following. We're assuming this because we don't know the real values, but let's assume that this value here now is 1. Okay. So that would mean, Leo, if you agree, that this coordinate, Leo, would be 0, 1, right? Are we okay up to that point, Leo?
Yes.
Okay, so remembering that if this is an odd function, it would mean that if I have a 0, 1, I need the corresponding value would have to be in 0, -1. Remember, if I substitute the value, I'm going to get the negative. Okay, that's why the mirror occurs here and here. Okay, is that clear, Leo?
Yes.
Now, let's grab another value, whatever value we want, just out of, let's say that this value here. What we're assuming values again, because we don't know the values of the function. Let's assume that this is -1. And let's assume that this point here is, I'm gonna say 0.5. This would mean that this coordinate is -1, 0.5. Okay? Are we okay up to that point, Leo?
Yes.
So what would the opposing coordinate be? It would be a 1. And what would be the y value if it's odd?
-0.5.
Correct. 1 and -0.5, which would be approximately here. This would be the corresponding mirrored value. That would mean that we're talking about this value here. And we would approximately be talking about this value here. And see how the values are mirrored, okay? And they're mirrored along the y-axis. I'm sorry, they're mirrored along the origin, okay? You see that there?
Yes.
Let me just draw this a little bit more marked so it can be in the notes. Give me a moment. And we can do that for any of the values, and it's always going to be mirrored on the other side. Okay. Now, we can do exactly the same exercise for the even. If I have this value here that's 1 and let's say that's the same value, it's -1, and this is 0.5. Then when we have the 1, we should also have 0.5. Okay, and that's how it corresponds with the evens. The same value is going to be reflected on either side. Okay. Okay, questions with this one? Was this one clear?
Can I stop sharing now?
Give me just one moment.
Mhm.
Screen grab here. Okay, give me a moment. Do you want to be in the image now?
Yes.
Yes, okay. That's good. So if you want to be in the image, Leo, just say something and give a thumbs up.
Cheese.
That's good. I like that. That was
Cheese.
good. That was good. I like the glasses. That was a good touch. Okay, good. Good job, you guys. Thank you. Let's jump over to, by the way, remember that we're going long until 12:40. If any of you need to go to the bathroom or step out for a moment, go ahead, please. And over at home, I don't know what you guys are doing, so be free and go ahead and do whatever you wish. Very, very quickly, please. Let's see, we've got, who's next? House Jokers, please.
So should I get those?
Yeah, let's do it here. Andres, and I'll help you out, just so, so Andres has the floor.
Okay, so I think, like, seeing the other, classmates, I think ours is kind of incomplete. Because we had to also like put the other part if it is an event or an function. But like, just looking at it, I think that the answer would be like in the first quadrant, like another U. Right? And in the third quadrant, like, another N.
Okay, let's do that. So this one is incomplete because we haven't, we weren't asked to determine if it was even or odd. We needed to replicate the even or odd. So actually, let me do this again. So let's do A first. So the original function is the one I'm going to draw in blue. And it goes something like this, like this. Okay? Something like that. Pretty ugly. Let me just draw the other asymptote. Here. And the asymptotes that are these lines here are also referenced. So we've got one there and we've got one here.
All right.
Okay, so if this is going to be on even function, which is the first one, what would we need to do here? How would we reflect this one?
Well, can I like stand up and point?
Let's do this. I'm going to draw the asymptote.
Okay.
This is interactively. Draw one asymptote there. So let's do this. Let's play a game here on this. I'm going to say 1, 2, 3, and 4. And I'm going to call this, A, and I'm going to call this B. What would you put where?
Put A in 2 and B in 3.
Perfect. Perfect. This is like a game show. If this is going to be even, then we would have to have a reflection along the y-axis, which is this axis here. We would have a reflection on the y-axis. Okay. And that would mean that that's what we would have. We would have a reflection of section A in 2, section B in 3. Okay?
Yep.
Perfect. That's the that would be the even one. And now let's do this would be A. And now let's do B over here. So we're going to do the same. We're going to draw this. I'm just going to make it a little bit smaller, a little bit more compact. That's why. One asymptote here. One asymptote here. One asymptote here. And the original function is going to be a u here and a u here. Okay, now let's try to do the same exercise. Let's call this 1, 2, 3, and 4. And let's call this A and B. So what's going to happen here is that now we're going to imagine that we've got a mirror that's going along origin. So everything is going to be mirrored along the origin. So what would we have there? What would we put where? Andres?
I believe A is going to be in 1 and B in 4.
Oh, okay. Actually, yes, but because it's going to look exactly the same. Actually, we're doing the mirroring along the quadrants like this. So it's going to look exactly the same what you said, but actually B is going to be in 1. What you said looks exactly the same as what I'm going to mention. B is going to be in 1 because it's going to be reflected, and A is going to be in 4. Okay, remember that this isn't done to scale. Okay.
Yeah.
And we're doing the mirroring in opposing quadrants. Okay.
Yeah.
So is that clear?
Yeah, that makes sense.
Okay. Good. Good job. Questions, Andres, and for the rest of the group?
No.
Okay. Good. Okay. Oh, it's actually the whiteboard. Okay, good. Do you want to be on the screenshot?
Yes.
Andres, okay, good. We hadn't done this about the screenshot. So 1, 2, 3. There we go. Perfect. Thank you, Andres. Good job. Yes, go ahead. Questions with this one? Okay. Good job, you guys. Let's see, let's go with, that was 18, that was jokers, right? Yes. Let's go with algebras 24, please.
Okay, I did this one. So on this one, it gives you the 2 points, which is -2 and 1, and 3 and -4, and the function of y equals f of x. And it tells us that the graph f shifted down 5 units. So what I did here was just move the points down 5 points and graph it again.
Okay. So, good job. So right now for this reference, we don't know what type of graph it is. You're assuming it's a line. That's not a problem. We're assuming it's a line, and the only thing we need to do is to locate the new coordinates for the points. So good job here. Let me just reinforce a couple of things here. So what's happening here is that we've got 2 points, -2, 1, which is this point here. This point here is -2, 1. And this point B over here is 3, -4. And so the graph, or the function rather, is being shifted down. My stand is shifting down. So it's being shifted down 5 units. Both of the points are being shifted down 5 units. So if it's being shifted down 5 units, we're basically affecting the y. So if we've got a 1 here and we shift it down 5 units, it would be equivalent to subtracting 5 to the 1. So if we do that, we're going to get -2, -4. Okay, 1 minus 5 is -4, which is what we've got. And then for this other point, if we substitute, or if we subtract 5 to -4, we're gonna get -4 minus 5 is gonna be -9. So this would give us a 3 comma -9. And that would, those would be the 2 points, okay? Good. Give me a moment here. Okay, good job. Nope, this was Arturo, right?
Yes,
Okay, perfect. Do you want to be on the screenshot, Arturo?
sure.
Okay. Are you excited about that?
Yes.
Let's show that excitement, please. Because I was
Okay,
like,
then.
sure. I mean, do you want to be in the next? Do you want to be in the next Marvel movie? You're sure. I ain't got time. Okay, so 1, 2, 3, say something. Do
Guess
something.
so.
Again? Just keep
Guess
talking.
so.
Perfect. There we go. Thank you. Thank you, Arturo. Good job. Let's go with House Deadly Signs, and we've got problem 26, please.
Okay, the problem 26 is that the graph is shifted to the right 1 unit. So in the value of x, we put +1 in each point. And at the end, the result was -1, 1, and 4 minus 4.
Correct, perfect. So basically, if it's shifted to the right, it's being moved along the x-axis towards the positive side. So if it shifts to the right, the function is f of x minus c, and so we add the value. In this case, it's shifted right by 1 point, and so we add that. We add that point, that one. I was looking for the instructions. There we go. Right 1 unit, so we add that 1 unit. So -2 plus 1 is going to be -1, and in the 3 we add 1 is 4, and that would be that shift. Perfect. Well done. Okay, good job. Thank you for it. Let's go with House Pi Waves 28.
Give me a second.
Yes, go ahead.
Yes, here's problem 28. It says that the point -2, 1, and 3, -4 are on the graph on the function y equals f of x. Find the corresponding points on the graph obtained by the given transformations. Then the graph of f shift down 3 units and to the right 5 units. So here we have the first point, -2, 1, and here's the original line, and the 3 and -4. Then the point, I think it was this one. Yes, we shifted down 3. So 1, 2, 3, and then 5 to the right. 1, 2, 3, 4, 5. Here's the first point that we shift. Then we have here the second one. So we go 1, 2, and 3, and 5 to the right. And here's the second point. And then we draw the line, and this is how it ends up.
Correct. So what we're doing there is the same situation. Now we've got a combination of 2, so we shift to the right. I'm sorry, we shift down 3 units. That means that we are subtracting 3 from the y. So -2 minus 1 turns into -2 minus 2, and 3 minus 4 turns into 3 minus 7. Then we shift 5 units to the right. That means we're adding 5 to the x. So the -2 turns into 3, and the 3 turns into 8, and that gives us the points 3 minus 2 and 8 minus 7. Okay, good job, correct. Thank you, Leo. Well done. Okay, let's go with House Jokers, problem 30. Okay, Luis, let's let me put it here. This is the camera. So here's Luis. Go ahead, Luis.
I'm not sure if it's correct, but it was just to reflect on the x-axis. I don't know if it's a procedure to do it, but I just changed the sign of y in order to, well, reflect the line.
Okay, let's look at these. Okay, let's look at these. I'm sorry, Luis. So the original point is -2, 1, and 3 comma -4.
That's original.
And so what we're doing is it's reflected on the x-axis. That means that this point should shift over to this side, and this point should shift over to this side. Okay. If we're shifting the points, that means that the x value is going to remain the same, and the y value is going to turn negative. Okay, so if we've got -2 comma 1, now we're going to have -2 minus 1. This would be the reflection here. Okay. And if we're reflecting the 3 minus 4 along the x-axis, the x is going to stay the same, so the 3 stays the same, but the -4 is going to turn into 4, and we've got 3 minus 4. A reflection on the x-axis is equivalent to multiplying the function or the y by minus, which is correct. Okay, good job. Good job. Questions with this one? Remember, reflections on the y-axis is going to be equivalent to multiplying the y by -1. If this were a reflection on the y-axis, we would have multiplied the x by -1. Okay. Okay. Good job. Thank you, Luis. Okay. Good job, you guys. Let's
Teacher,
yes, go ahead.
may I go to the restroom?
Yes, of course.
Thank you.
Sorry. Okay, so we've got this was House Jokers, right?
Yes.
Yes. We're back to House Algebras. We're almost done. This is good. We're in good time. Let's go with problem 32 with House Algebras.
Sure, I just realized I did it wrong because the problem, it says that y is equal to f of x. So I don't know why I thought f of x, the function was just x, so I did wrong, but I already corrected it.
Okay.
But I don't have a graph, so is it okay if I present it without the graph?
Yes, sure. And we'll walk through it. And we'll do the necessary corrections in the original PowerPoint. Okay.
Okay, so the problem gives us that 2 points and in the graph that's A and B, and that's the line that goes down. Well, I guess it was a line. I must have wrong.
We mentioned this is interesting because all of you, the problem is just giving us 2 points. And for the purpose of visualizing the problem, all of you considered it that it was a line. For the purpose of the problem, that's not, we don't know if it's a line, if it's a, we don't know the type of function. But if we assume it's a line, then graphically, it's correct. It's not a problem, okay? So yeah, we're assuming it's a line. If it weren't a line, those 2 points would still be a part of the function, okay? So assuming it's a line is not a problem. And speak a little bit louder. Imagine that you're screaming at the people at home and you want to get their attention. Let me do this, okay?
So the problem says that the graph of f compressed vertically by a factor of 1/4 unit, then reflected in the x-axis. So first we did the part that says compressed vertically. So in the PowerPoint of the class, it said that when you compress vertically, the c it's that y is equal to c times f of x, and c it's always a positive constant. So we multiplied the f of x, that it's y, times the 1/4 unit, and that gives us a new 2 points, and that is here, n minus 2 and 1/4, and 3 n minus 1. So now we need to do the other part that says reflected in the x-axis, and that's y equal to minus f of x. So we just multiply the new y coordinate times minus 1, and it technically just changes the sign of the y.
Correct. Good job. Let's go up to the first one. So this has 2 parts. First, the function or the graph is compressed vertically by a certain factor. That means that the y is being multiplied by that factor. That's the compression. It's a long y. So basically what you're doing there is you're grabbing the y, which in this case is the 1 and the 4, and multiplying it by 1/4, and you get a new coordinate. Then the reflection along the x-axis, we just did one of those examples, occurs by grabbing the positive is going to, the positive in y is going to turn into negative, and the negative of y is going to turn into positive. So basically we're multiplying by -1, and that generates the reflection. So assuming that this were a line, I believe that the dark brown is the original line. The compression and reflection, could you go to the next slide, please? And then the compression and reflection would be the new brown line, which is a brown line that's, first off, it's closer to the x-axis. That's the compression. And the other is that it's flipped along the x-axis. I'm doing a lot of hands gestures and being very like, and nobody's seeing me because everybody's seeing Fernando. So I'm going to switch over to my camera. So blah, 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 switch, etc. Okay. Is that clear? So good job. So this procedure isn't this way in the PowerPoint you guys sent me. Can I ask a favor for you guys? Could you please correct the PowerPoint, adding these slides and correcting that part and sending it to me again? You can send it to me via WhatsApp. Okay, just so when I upload the corrections, we have the corrected files. Okay, good job. Thank you. Okay. Do you guys feel weird when you're on the camera? No? You're cool? Sometimes a little bit. Yeah. It's odd because if this were, again, going back to pre-pandemic, if this were a normal class and you were to solve a problem in the whiteboard, like what you did, Miguel, you just kind of come up to the whiteboard and solve it. It's kind of normal. But if I put the camera in front of you, it feels weird, doesn't it? Yeah. For some of you, okay. For some of you, maybe not, but that's part of what we're dealing with. Okay, let's go with House deathly signs and problem 38.
Okay, well, this is problem 38. I'm gonna be presenting the first 2 letters, B and D, and letter B, we can see the -1 and the function, and that's indicating it's gonna shift 1 unit down, in this case to the origin, which is 0, because it was originally in 1 in the y-axis. And letter D, it shifts half pi unit, I don't know how to say it, half a unit to the
Pi divided by 2.
pi divided by 2 to the right. Same thing because of the function, the minus pi divided by 2. And yeah.
And then we have the negative sign inside with the x. So that means that the reflection is on the y-axis. And if we did that, well, we think that it would stay the same. So we didn't do anything on that one. And then we have,
Let me just stop you there for a moment, Anna. That's a good observation, and it's correct. Why is that? I'm going to ask you a question, Anna. What are you studying?
Industrial Engineering Global Program at CETIS.
I mean, that must be really difficult. And you must be really smart. Perfect, perfect. We just saw half of your face, but you transmitted everything perfectly. But now I'm going to ask you the real question, Anna. Is this function, the original graph, just by what you're seeing, do you think it's even or odd?
I think it's odd. No, even.
It's even because it's reflected on the y-axis. And guess what? If I substitute minus x, which is f, in an even function, I'm going to get the same function. Remember? So what you just mentioned is correct. If you do a reflection along the y-axis, you're going to get the same function. Why? Because it's even. Okay? So yeah, f is correct. Please go ahead.
Okay, and the last one, well, we have the negative sign here. So the reflection is on the x-axis. So we do this and we have the 1/2. So we moved it half a unit.
Okay. Remember that the 1/2 in this case, or the value that's multiplying the function, that's a compression or a stretch. So that the only thing that means is it's going to get closer to the it's going to be getting closer to the y-axis. Okay, and these are sketches that we're doing. Okay, good job, and I really love the fact that you copy pasted the same graph and you just kind of did it with colors. That was perfect. That was really well done. Okay, good job, you guys. Good job. Thank you. Well done. Okay. Now we've got house pi waves and problem 40. House pi waves are, there we go, perfect.
Okay, can you hear me, teacher?
Yes, this was good.
Okay, so our team, so we solved problem number 40. Okay, it states the graph of fx equals x to 2/3 stretched vertically by a factor of 3 units. So stretched vertically, so it states that if we have a fraction, it stretches. It doesn't stretch up, right? It stretches this way, right?
It's stretched vertically. It means it's stretched along the vertical axis, meaning up and down.
Yeah, my bad. Yeah, I can guess. Then it shifted right 2 units. And can you hear me, teacher?
Yes.
Okay, my bad. Some of my grandma right now, so.
Don't worry. No worries.
And it says to stretch a graph by a factor of 3 units. So we have y equals 3fx. So here it states that if we have, I wrote it down somewhere. Okay, so we have by factor 3 units. and then it says to shift the graph right 2 units equals y equals f to the x minus 2. So since we have a negative, it's going to be moved to the right. That's what it states here. So we already got the y equals 3 of x, which is the one that stretches vertically. And all we did was a fraction it. We put into a fraction, an equation of it.
Okay, okay, let me stay on the slide, please. That's just for all of you guys, let's practice a little bit if we're going to be presenting. Okay, so it's very important to not look at a slide and seem like it's the first time we see it. But the procedure is correct. So basically, we're giving a function which is x to the 2/3. And we're doing some stuff to the function. So in this case, we're stretching it vertically by a factor of 3, and we're shifting it right to 2 units. So we're going to do each of those things. So first, a stretch or a compression. Remember that we're talking about the same thing. A stretch or a compression means that I'm multiplying by a factor. And so to stretch a graph 3 units, like it says here in the slide, and Jesus was mentioning, to stretch a graph by 3 units, it means that we're multiplying the function by 3. We're multiplying by 3. And then if we're shifting the graph right 2 units, that means that a shift to the right, it means we're subtracting the units. And so that means that it's f of x minus the units, which in this case is 2. Now, if f of x is x to the 2/3, it means we're multiplying by 3, and whatever is inside the function, we are subtracting 2. And that gives us the complete function, which is f of x, 3 times x minus 2 elevated to the 2/3. Okay? The procedure is correct. Okay. And it's not asking us to graph it. It's just finding the new expression after we've done the adjustments or the shifts. Okay. Okay. Good job. Thank you. Thank you, guys, and thank you, Jesus. Now let's go with house jokers. So we've got the last one. We did good today. Let's go with house jokers.
We are not very sure what we need to do. So first we just draw the first graph, then reflect it on the y-axis. Then we shift it left 5 units, just like that, and down 10 units. But we're not sure if it's correct or we need to do something else.
Okay, I'm sorry, let's go through this. So, okay, basically what you did there is you identified the model for the graph, and then you did all the operations and got the new graph. So this procedure is correct, okay? But what we want to find is we want to find the equation for that graph that we just represented, okay? So let's do that part, similar to how we did the other. And since you're not that comfortable with the camera, I'm gonna let you go, Luis, okay?
Oh, it's okay.
No, I know, I'm joking. So this procedure is correct. We're basically taking the graph and we're applying all the shifts, but we want the equation. How would we find the equation for this? Well, let's follow the same procedure we did with the other one. F of x is 1 divided by x. It's reflected in the y-axis, okay? Reflected in the y-axis, then shifted left 5 units and down 2. So first off, we're going to do this step by step. I'm going to call this 1. I'm going to call this 2. And I'm going to call this 3. So 1, reflection in y. This would mean that f of x now is going to be equal to, or we're going to substitute minus x into f of x, okay? So that would mean that f of x now is going to be 1 divided by minus x, which is the same as minus 1 divided by x, okay? Then 2. It is shifted to the left 5 units. And a shift to the left means that we are adding that amount, the units, to the function. So that would mean that now f of x would turn into f of x plus 5. Okay, so to the one we originally had, now we're going to say f of x equals minus 1 divided by x plus 5. Okay. And lastly, it says that it's shifted down 10 units. It's shifted down 10 units. This would mean that f of x, if it's a shift down, now we're going to have f of x minus 10. And so this would mean that the new f of x is going to be f of x equals minus 1 divided by x plus 5 minus 10. Okay. And this would be the equation that we're looking at. Which would be equivalent to the graph that you guys did, okay? But that would be the equation that represents it with each of the steps, okay? Okay, questions with this one? Okay, good job. Good job, you guys. We got through the workshop exercises. Good job, okay?